Kia ora, Year 11 and 12. This is a really good question that Tejas has asked me to do. It's from an old AS paper. If you're in the A-level class as well, I think it's worth having a look at. It's just a little bit different from usual. So we're told that we've got an acute angle, x radians, is such that tan of x equals k, and k is a positive constant. Express in terms of k the following three things. So when I see this question, the first thing I think about is that drawing the graph of the tan function is going to help me. But the next thing I notice is that we've been told that the angle we're talking about is acute, and that's really going to help me. So that means that we can start off by just drawing this curve. So let's draw a decent tan graph. I'm not doing this in GeoGebra on purpose because I want you to see how useful drawing the graph is, and you won't have GeoGebra with you in the exam. So I'm going to draw a whole chunk of the tan function. So it's a bad graph, but it's good enough. Now, important things on here are that the asymptotes are sitting at pi on 2, and then the next one's sitting at pi on 2 plus pi, so that's 3 pi on 2. If you're doing AS and you're still not that confident with radians, it's important that you can switch between them and pick out the special values. So what we're told is that tan of x is equal to k, and that x is an acute angle. So that means that x is somewhere between 0 and pi on 2, or 0 and 90 degrees, if you're thinking in degrees. So this line here is k, and this is my angle x here. And once you look at it like that, the first question is pretty easy. We're asked to figure out what is tan of pi take away x. And if you've done level 3 trig and you're in the A-level class, you will do this lots and lots. But if you're in AS, you probably haven't done it as much. So this is 0, and this is x. So we've moved from 0 into x, and we've found tan of x is equal to k. So where is pi take away x sitting on that graph? Well, pi is here, and if we move back x units, we get to pi minus x. And by the symmetry of the graph, we can see that this value here is negative k. So tan of pi minus x is equal to negative k. So that's the first one marked done. Now the next question we look at and we go, oh, maybe I can do it the same way. So let's clean up some of this. We're now looking for tan of pi on 2 minus x, or 90 degrees minus x. But the problem is we haven't got any nice graph symmetry that we can use to go from here. This is from here to x. But from pi on 2 back x doesn't get me anywhere similar. The clue is in this. The acute angle x is such that tan x equals k. So the other thing we can use here is a little right angle triangle. Let's draw our right angle triangle and see what we can put on it. So here's my angle x, and we know that tan of x is equal to k. Well, tan of x is just the opposite over the adjacent. So we can draw in my right angle, and we can put k here, and we can put 1 here, right? This is the adjacent side. And this is the opposite side. We know that angles in a triangle have to add up to 180. So this angle here is 90 minus x, right? Or pi on 2 minus x, because this is 90 degrees here. And that means that tan of pi on 2 minus x is equal to 1, the opposite, divided by k. Right? So there's my opposite side, and there's my adjacent side. So the answer to that one is going to be 1 over k. Right, now that's going to help me with the last question, where we're asked to find sine of x. Again, we can use the right angle triangle. I'll just get rid of some of this. And sine of x is the opposite over the hypotenuse. So sine of x is going to equal k divided by h. And we can find Pythagoras, use Pythagoras to find that value. So sine of x is equal to k divided by the square root of 1 plus k squared. So that's all there is to it. And I really like that question because it links up two very important things in Trig, which is the role of the right angle triangle when I'm in the first quadrant, and the graph and all of the lovely symmetrical things that happen in trig graphs. And those are the two main strategies that you want to use in a question like this one. Thanks for watching.